here's a little different perspective. And IGUS is going to be going to a conference in Hawaii in 2 weeks, and this will be talking about this very topic, okay, developing the moon. And Turkey is a signatory of the Moon Treaty, 116, and that could be quite important. So we're going to look at the moon as a stepping stone to the universe. We're looking at a lunar development roadmap, because now we're looking at a paradigm shift in how space is approached in the future. It's no longer going to be who's going to plant a flag on some alien body, but it's actually to develop industry on the moon and to exploit lunar resources and have people living there. Okay, so these are kind of roughly the topics. Now, there's a famous German scientist who went to the United States after the war, and he had this statement: if God wanted man to become a spacefaring species, he would have given man a moon. Okay, so we have this then. Because the moon makes things thinkable that if the moon hadn't been there, President Kennedy could not have stood up and said, in a decade we'll go to the moon, because going to Mars in a decade at that point would have been vastly, vastly more difficult. So the moon provides many, many opportunities. However, for the United States, President Obama, I think it was in 2011 or 2010, declared, we've been there, we've done that. We've got to go on to Mars. Okay, but things are now changing. This is from a workshop about 3 weeks ago, and looking at a lunar base for 10 people by 2022 for under $5 billion. Okay, and what frames that is something that I call the international lunar decade, which is more a concept that I'm pushing. And we have the laser pointer here. Okay, so we're looking at 2015 when this project is launched. Robotic probes, ascent-descent modules, robotic surveyors, building up communication networks, robotic site preparation. We're looking at an awful lot of robotics here in the initial stages of this. And then we look at the human element. Now, many people that are in the space game, when you say humans in space, they say, why do you need humans in space? You can do it faster, better, cheaper with robots. But there's many reasons why you want to do humans in space, and one of them is it's hard, actually. Doing the robots is easy, but when you put the human on the moon, now you have to provide for getting food to that person or persons. You have to recycle, you have to have the psychological, the mental environment all taken care of, so you have 1,000 more challenges to deal with than if you just sent robots to the moon.
What is this ISRO?
ISRO is indigenous resource utilization, or in situ resource utilization. Okay? Now, in situ resource utilization initially would say there's water on the moon. Okay, this is in the South Pole in some deep craters. There's evidence of billions of tons of water on the moon. Okay, and that could be used for consumption or used to make fuel. But then also, when you look at the composition of the lunar regolith, you have all the materials to build photovoltaic cells, to build structures, make glasses. So most of, probably at least 90% of the mass, and probably even more in time almost everything, you could make from the lunar materials. Okay. And the other element there is not only that you process the lunar regolith, you have unlimited solar energy. Again, you have cooling, which you need for many many things. And you have, you can make whatever these caves and structures, but the most important thing there would be 3D printing. With 3D printing, you can make almost any object you need on the moon, and that has been investigated already by ESA. Okay. So now, what these folks were looking at is that one of the reasons you go to the moon initially is that you would have seed banks, you would have also burial. People buried on the moon. How much, you know, the Taj Mahal was built in India for probably at our money would be billions. People will want to be buried on the moon because it's undisturbed, and people will pay for that. They're now paying for all kinds of other things. So that's, but one of the concepts I've run across is if you have a 1,000-person facility on the moon, that becomes self-sustaining, because the tourism and all the other facets you can do will be sufficient to provide the revenue. Now, what this idea is of the International Lunar Decade is a concept of working together, basically all the spacefaring countries working together to really understand what the moon is. We had the International Geophysical Year in 1957, I believe. This is to understand the Earth. But we need to understand the moon, and we also need to understand how we, human beings, can work together from all the different countries of the world on a different planet. Now, we've had some experience in that with the, let's see, which one do I shift here? I just go there. All right, so the International Lunar Decade is to understand the moon, all facets of it, in a way that yet has not been understood. So we would have probing missions, we would have missions to explore, to actually do some in situ resource utilization work, processing work, putting up our first photovoltaic systems. So if Friedman and Huntress, Friedman is was the founder of the Planetary Society, working closely with Carl Sagan, and they proposed in 2007 a proposal for an International Lunar Decade. And then we had a shift in administration in the United States. President Obama came in and said, we've been to the moon, we've done that, we don't need that anymore. And NASA shifted its perspectives. But in that time, the paradigm until this point has been that commercial activity extends only to geosynchronous orbit. There is no commercial activity beyond that. In fact, commercial activity to geosynchronous orbit started in 1962. 1962, the American Congress established the ComSat, this is the Communication Satellite Corporation, and that was a commercial. Now what we're looking at is a different era when the moon itself will become a center of commercial activity. And so these are stepping stones with the ILD.
So I have a very small question.
Yes, sir.
The last slide.
Okay. I think we can go back.
Yeah, so what is the actual advantage do you think is for a moon mission? Because this peaceful space development and cooperation is good for writing, but what actually you think that is the advantage for any moon mission?
What is the reason for it, or?
Yeah, advantage.
Yeah. Okay. Well, right now we need to understand the resource base, what is there, how to utilize it. We need to try things out to do that. With the understanding that this is if you're going to have permanent presence of human beings in space, off the planet of the Earth, the moon is the logical stepping stone to get there. Okay.
Well, that is actually assumed, but for example, if let us say one country has done this, then other countries may take the data. That those data are actually available for anyone.
Yeah. There is significant data already available.
Already available, but still other countries are investing a lot of money for the same.
They're investing, so they need to pool their resources. and work together.
So-
This is one of the ideas on how you can speed this all up, so that by 2022, there could be a 10-person moon base on the moon, okay? Based on existing technology and without really breaking the budget. You know, this is now possible. We got Elon Musk, dramatically reducing launch costs, and then we got the miniaturization that we see in the explosion of small satellites, and then we're also looking at much lower costs with the 3D printing on the moon of building things on the moon. So cost, yes.
Actually, about the launching costs, I have a little bit some secret information from Russia, that they are very intensively this moment working on adapting kerosene as a rocket fuel, and they have a very good success about disperse this fuel with some additives in a plasma,
Yeah.
and then this plasma are boosting this flame speed so much that it becomes even better than conventional rocket fuel.
Yeah.
And so they hope that they can diminish launching costs at least 10 times or maybe
10
even
times,
50
yeah.
times.
No,
So probably next year we shall see some big changes in that.
I think we're going to see dramatic changes in launch costs. I am aware that Russia has plans for their moon base by 2035. I think it will happen much faster. Okay. So once the idea is not just to have the moon base, but there's the space between the Earth and the moon. There are sites where these Lagrange points, which are ideal sites for actually having fuel storage. So the rocket that is launched from the Earth can be refueled, so it can go further to Mars, and now you no longer have to use the kerosene even, because you have the fuel is derived from space. Okay, so the cost of getting there is going to be down, but you have to launch much, much less in the future. So, all right. So anyway, so I'm just looking at this. What we're looking at now is we're leaving the exploration paradigm, and now we're looking at actually developing infrastructure in space, and that with commercial opportunities as well as many others. It would be awesome to have a massive, large-scale telescope observatory on the far side of the moon. We don't have interference from the Earth, and you can observe things better, and there are much more. So lunar ventures should be global. I certainly would, so you avoid duplication, lower costs, and pool knowledge and resources. And this is why the International Lunar Decade needs to be that. It needs to be the pooled effort of literally of all mankind. So we have the precedents, which was the International Geophysical Year, and these other years. And based on these precedents, in the conference that you'll attend, they'll be talking about this very thing. So, and here are the cooperation models. What the discussion now is to have a lunar development corporation that would have partners from national funds. So let's say India, US, China, Russia could be partners, and now you can pool resources and you can do more with those resources because you're lowering costs, and commercial businesses will be involved in making things actually happen. It's not going to be the government saying we're going to go to Mars. It's more going to be commercial businesses competing to make things happen in this new paradigm. So now we've got the Antarctic model. Conclusion. Okay. So this will be one of the steps, I believe, will be the International Lunar Decade. And at the end of this period, we should see the fully developed idea how the different countries can work together to make, whether it's lunar bases, lunar industry, and then the industry itself will be from different countries operating facilities on the moon, in space, and then eventually, certainly the asteroids as well. We do have 2 U.S. companies that are looking at asteroid mining. So here's the paradigm shift. The moon hasn't changed, but we have changed. The small sat industry is exploding. 3D printing is now maturing, and that has already been looked at as for use on the moon. The cost of photovoltaic systems has dropped dramatically, and then all these lessons can be applied to manufacture on the moon. And the asteroid mining has progressed. We do have serious money going into that now. And then we've got this idea of the lunar habitat. So what happens is when you have in situ resource utilization, you eliminate Earth production costs. And again, when you're doing things in space where there's a vacuum, with zero gravity or much lower gravity, there are things you can do in manufacturing that you cannot do in the gravity well, with plenty of oxygen around, where you have to create vacuum. So we'll be able to manufacturing things. Again, and then we got microwave or laser transmission to the Earth, solar furnaces for larger vacuum, and again, the benefits of vacuum processing. And this is how the moon looks. That is an actual shot. And these are some ideas. Low-cost lunar economics. This is actually out of a class that's held, I believe it was the University of Southern California, and they're saying, okay, create a 1,000-person lunar colony. And so they're saying the cost, you'd have to pay people $150,000 a year as an average labor rate on the moon, okay, to get people there. And you have to labor rates 2 to 5 times the Earth, and stay from 1 to 5 years. So these costs are being calculated, and again, the model is that if you achieve the 1,000 people, you will basically have a facility that can stay. So tourism, entertainment, mining. This is helium-3. This is for fusion energy. Research of many kinds that is hard to do here. These people assume that you'd have diplomats from each of the major countries would be sending 4 diplomats to the moon. Now, is that a logical idea? I suspect there is a possibility. And then we got all these things need research. And one of the things that you may have run into is there are more and more people that can't get permanent jobs in science. They get their PhD, and now they're in a permanent postdoc track, or they're driving a cab in New York or something. You know, so if you do these kind of things, you're going to have jobs for every PhD on Earth. You know, because you're going to need to develop a whole vast range of new things for a totally new environment where people have not lived, worked before, and that's why you need people in space. So the other thing is pervasive supercomputing. Well, these are the 2 companies that actually I mentioned today. ConnectX, big data processing capabilities in orbit, server sky, constellations of servers in orbit. ConnectX is, they're actually in a state where they're looking at serious financing. Server sky is more of a technical concept at this point. But the fact that on the moon, as we do things, that you have those supercomputing capabilities available changes the equation, because you don't have to test it out on the Earth in a lab ahead of time. You can actually do it more or less on the fly. Now you're there, you try it, you model it on your supercomputer systems, and you can try various parameters and basically do what would take decades here, maybe in a year, because you can literally try things out and model at the same time. You model, you try, model again, try, until you've got something that works, and now you're making perfect photovoltaic cells for your large-scale system. So, and work can proceed in parallel on multiple tracks. So while somebody's working on the ecosystem engineering aspects of it, you know, to sustain life in the long term, somebody else is working on the architecture and extending the tunnels below the moon's surface, and somebody else is working on the long-term farming application, while somebody else is working on the astronomy, and they all work concurrently without having a final answer. They're creating things as a group simultaneously with the intermediation of the cognitive intelligence system. So this would be a system like Watson, those kind of systems. So, yeah, so we got the stuff on the moon. You got internal consumption, construction, and then we're going to be selling fuel, materials for the people that want to go to Mars, for the asteroid missions, and so forth. So these operations, these manufacturing operations, and all these support functions will be supporting the other functions that will be going on as space development actually explodes, as opposed to simply being, again, a government-directed effort that we're going to go to the moon in a decade. We're going to go and build on the moon and build a civilization in space. So is that it? Challenges, okay. So the challenges to work on. I think one of the challenges to work on is the Moon Treaty. And does anybody know what the Moon Treaty is? Okay, there was the Space Treaty, that dates from the 60s. The Moon Treaty dates from 1979. And it was negotiated for a decade. And one of the reasons it was negotiated so long is that there's a clause in there, is that the resources are the common heritage of all mankind. In effect, the moon, Mars, everything in space belongs to all of us, and no one can claim it. But that raises problems. You know, if you're gonna, how can you mine the moon or tell somebody that, hey, it's worth your time to develop a facility on the moon if you can't own it? Okay, so there's a need for attention. Well, the Moon Treaty attempts to deal with that to a degree, but it has been ratified by only 16 countries. So it's treated as a dead treaty at this point, but Turkey did ratify it, and as did the Netherlands, and as have, well, I can name all the other countries if need be. But I think myself, my conviction is that the surest route to the future would be actually to ratify the Moon Treaty and to work with it and develop what they call an international regime. This means how the countries of the world can work together to develop the moon, but it does not have to be a massive UN bureaucracy. It can actually be lean, mean, fighting machine type of operation that gets things done faster, better, cheaper, and so forth. We do have a problem of large upfront costs, but right now the world is awash in money, looking for investment opportunities, and they can't find them. So we've had some ridiculous things, like in the United States, you have the real estate bubbles. Here would be investments for long-term future on the moon that would stay, you know. And then we have the results of investment must be shared. One of the things that's emphasized in the Lunar Treaty is that the developing countries that never flew, never had a single person graduate with maybe a physics degree, still have the rights, okay, to the moon. And that has made some people in the United States angry. They said, why the hell should we share anything with those people? They did nothing for this. Well, that has some answers. One of my answers is, India developed a zero. Where would we be without zero? Or the Arabs developed algebra. Where would we be without algebra? We would have, you know, the foundations we stand on are from all mankind. We are one planet, and we need to think about all these things that way. So, Lunar Development Corporation, purpose, develop, implement the international regime for development of the moon, and essentially space for all. This is not space for having the rich countries go to the moon, it's space for all of us And that is possible. The technologies that are coming will make it possible so that if you aspire to work on the moon in a decade, you can make that opportunity happen. So I think this is, okay, campaign to ratify the Moon Treaty. Well, we have, we're working on this actually. And then the international regime. There's the examples. I have actually written an article advocating that the International Space Station did receive the Nobel Peace Prize. And the reason is it has been literally decades. We've had many countries of the world work together, and it is a true example of peaceful use of space. And that should be an example for all of us. So these are some of the examples of international regimes. Can own billions and billions what's being done. So here we deal with some of that. Phases of development. These are things I actually did somewhere else, sorry. Okay, crowdfunding initiatives. So these are all ways to build. So Lunar Development Corporation is not a UN bureaucracy. It's an economic development organization combining investment from governments and the private sector. And COMSAT, when it developed, was totally government. Now it's totally private. And I think this could work the same way. Initially, government money stimulates investment, stimulates innovation, and then what it becomes, ultimately, is private business that operates on its own. Government's role at that point is different. So there we are, and then this is Earthrise. And we are looking at the Earthrise Foundation, the Earth rising above the moon, and rather than the sunrise, but the Earthrise is also the rise of all of us people on the Earth, lifting beyond the well of gravity into the freedom of outer space. So, okay.